best part of this class is it's not really democracy so much. So think like 1940s Germany. That's probably a little bit closer.
Wow, Hitler.
Okay. Add 2x to both sides. Y-intercept of 1. Slope of 2, or better yet, as a fraction, 2 over 1. So we'll go up 2 over 1. And, oh, that's a terrible one.
Can't cheat.
And, double up.
I tried.
Okay.
I want everybody to feel better than me.
As I noted, so we've graphed one line. As I noted in our little introduction here, our system of equations is simply going to be where we're comparing more than one equation at a time. So our system of equations is just comparing more than one equation at a time. For us, we're going to look at 2. We're going to start with just solving a system of 2 equations. Okay. As you move on, as you go to Algebra 2, you look at systems of 2 and 3 equations. And you can go on beyond that if you want. As you kind of grow up and you add more variables into the realm. But we're going to stay with 2 for right now. We're going to compare more than one. For us, it'll be 2. We're going to look at comparing 2 different equations at once and how they interact, what's going on. The solution to a system of equations is simply any shared points between the equations. For us, when we're graphing 2 lines, how many places can 2 lines cross? One spot. Well, we'll discuss that there's actually 3 possibilities. They either don't intersect, they either intersect at one spot, or they completely overlap. So they'll have what's called an infinite number of solutions. We'll get there later. For us, we're looking for where they cross. So it's simply where the lines cross. Okay, is all we're looking for. In general terms, we're looking for where they cross. So on a graph, it's pretty easy to see. We just look at the 2 lines, wherever they intersect each other, that's the solution. As we move on, as we look at more what are called algebraic ways to solve these, so with using equations and less visual, more with the equation, with combining the equations and doing some various techniques, you may lose sight of what we're trying to do. But in the end, it all boils down to we're trying to figure out where 2 lines cross. So our solution is always going to be a point. It's always going to be an x and a y. It's a point. Okay? On a graph, it's pretty easy to see. When we move forward, just got to keep reminding ourselves, looking for a point. Okay? We're going to start with kind of an old school method, what's called the graph and check method for solving. So, as I noted before, if we're going to compare 2 graphs or 2 system equations, it makes sense to just graph them both. And that's essentially all of our methods going to be here. Step 1 is simply graph the equations on the same piece of graph paper. I'm going to call same axes. The same spot. We graph them in the same piece of graph paper. Once they're both graphed, once they're graphed, we're going to identify the solution. How am I going to identify where the solution is going to be? How do I know? What am I looking for? Sort of the reminder. When I graph both lines, what am I looking for? Or what are you looking for? Yeah, exactly. Looking for this. It's the solution. the solution is where the lines cross. So figure out where that spot is. Identify that point. Just a reminder, it's an x comma 1. It's a point. The last piece is probably the most important piece for this method is once we've identified what the solution is, we really need to check the solution by plugging in the solution back into each equation. Can anyone just hypothesize, think about right now, why is the check going to be really important for us when we're graphing these things by hand? Okay, make sure it's right. Why is it going to be more important? We always want to make sure our solution is right. But why is it going to be extra important if we're graphing and solving these graphing by hand? Yeah, it could be. Can you repeat that a little bit louder, Jack?
It'd be easy to make a mistake.
It's really easy to make a mistake when you graph. How many people draw perfect straight lines every time?
I wish.
Yeah, I don't. I don't either. So
You guys a little cheaty.
yeah, I can cheat. I can cheat on a smartboard. You guys unless you're using a super precise ruler every time and plot a lot of points, it's really easy to make a mistake with this. As far as just you could graph the lines kind of correct, but maybe you curve one line a little bit. Maybe it kind of is off a bit. Checking with this method is probably the most important thing you do. Is simply just take that answer and take an extra couple seconds out of your day and plug in x and y back into each of the equations and just make sure that yes, indeed, this point actually is on both of those lines. Okay, it seems kind of dumb. It seems kind of long or extra work, but it's very important to make sure that what we're doing is actually working. Okay? Graph. Figure out where they cross. Make sure that's where they cross. That's all we're doing. Okay? That means we're going to have to do some graphing, a bunch of graphing today. Let's get started. Let's get the fun going. So, on the back side. Solve this linear system by graphing. So, we need to graph the lines, we need to figure out where they cross, and we need to make sure that's where they cross. So if I'm going to graph these things, what are we going to do? How do we graph those things? Oh boy. Okay, in general, let's put them in slope-intercept form. Let's put them in y equals mx plus b form. Okay? Let's start there. What do you want to do? Want to write them both in y-intercept form and then graph them after? Or do you want to do them write in y-intercept form and then graph right away? It's up to you guys. I can do whatever.
That's the easiest way.
Easiest way. Okay. Let's just work through, let's just rewrite and graph one line, then we'll rewrite and graph the second. Okay. So let's start with our first one. And we'll call it the first line. So negative 5x plus y equals 0. Let's start just like we did in the warm-up and write this in y equals in slope-intercept form. So if I add 5x to both sides, I get y and 0 plus 5x. I think that's 5x. Yeah. Rewrite slope-intercept form. Let's graph this. So I need to identify the slope and the y-intercept. Okay, what's the slope of this line? 5. So let's multiply to x. I'm going to even write it as a fraction, because that's going to help me as I do rise over run. What's the y-intercept of this line? 0. There's nothing added to this, so we represent nothing with 0. Okay. Okay, so my y-intercept is 0, so I'll put a dot at y equals 0. There. I have a slope of 5 over 1. So that means I'm going to go up 5, 1, 2, 3, 4, 5, over 1. And I'm going to draw a straight line. And with any luck, I'll get a straight line. It's close to a straight line. Okay. Okay, one line graph. Yeah, I graph the second one. So let's graph the second one. And y equals mx plus b. So how about we get rid of this positive 5x, subtract 5x from both sides. I get y equals minus 5x plus 10. Okay, so what's the slope and what's the y-intercept? Slope is, say negative 5. Negative 5 or negative 5 over 1. What's the y-intercept? 10. Okay. This like 7th grade math is coming back to us. So we're going to plot the y-intercept at 10. So I'll count up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have a slope of negative 5 over 1. So I'll go up and down negative 5. So down 5. Left and right positive 1. So down 5. 1, 2, 3, 4, 5. To the right 1. Look at that. So step 1 is done. I've graphed both lines on the same axis. Now what do I do? How do I find the solution of this now? Figure out where they cross. So where do they cross? What's the coordinates of this? Right 1, up 5. The solution seems to be 1, 5. What's the last thing we need to do? Check. Plug it back in. Make sure that it actually works. You can plug it into these, to the y equals if you want. You can plug them back into the originals. It shouldn't matter. If your equations, if you rewrote them correctly, it doesn't matter. So I'm going to plug in 1, 5, x is 1, y is 5, into each of these, and we can quickly check. You can do this in your head if you're a good mental math person. If you just want to jot down your paper, it goes pretty quickly. We'll just make sure that these are actually the solutions. So I have what? My first equation was negative 5x plus y equals 0. So I'm going to plug in 1 for x and 5 for y. Or is negative 5 times 1 plus 5 equals 0. Is negative 5 times 1 plus 5 equal to 0? Is this true? Yeah, negative 5 times 1 is 5. What's negative 5 plus 5? That is 0. Yeah, that's good. Yes. That's good. So make sure it works on the second one, and we're good to go. So what was it? 5x plus y equals 10 was the second equation. So is 5 times 1 plus 5 equal to 10? 5 times 1 is 5. 5 plus 5 is 10. Yes. So we did graph this correctly. This is our solution. 1, 5. Good to go. Okay. Graph both lines. Figure out where they cross. Make sure that's where they cross. It may help to use a ruler to make sure your lines are straight, because crooked lines can lead to problems, as hopefully you're noticing right here. What I want you to do is, we gave last hour 5 minutes and we end up using like 15 or 20. So let's maybe try for the same goal. Let's try to shoot for 5 minutes, and if you guys get done early, then we can get some extra stuff. Let's shoot for 5 minutes to try to get these next two graphed. Word of warning, this middle one here, you're going to have a couple fractions in one of them, so don't freak out.
Really?
Really good. Okay. Let's get started. Let's shoot for being done with these two examples in the next 5 minutes. Make sure you ask questions, raise your hand, get some help, and make sure everyone's graphing and everyone's good to go before we move forward. Okay. As I know some of you are still finishing up, I want to look at least the first solution here. Maybe we'll get to the second. Our first one here, let's solve our first equation. So let's get y by itself here. So I need to add x to both sides. And we get 2y equals x plus 3. I don't want 2y though, I want 1y. So I need to divide everything by 2. And it could help actually if we write in, what's the hidden coefficient here in front of this x? What's the hidden number multiplied to x? 1. This could help out to figure out what the slope's going to be if we put that 1 in, hopefully. So then what's the slope, therefore, is 1 over 2. The y-intercept is therefore 3 over 2. This is where some of you kind of got scared and choked up. The y-intercept, we're going to put on the y-axis. So we're going to put the value of 3 halves on here. 3 halves is the same as 1 and 1.5, which is 1 and a half, half of 3. The slope tells me up 1 to the right 2. So from here I'll go up 1 to the right 2. And draw a line. My second equation, I'm going to get y by itself, so I subtract 2x. And I get y equals minus 2x positive 4. Y-intercept of 4, 1, 2, 3, 4. Slope of negative 2 or negative 2 over 1, so I go down 2 to the right 1. Negative 2, positive 1, down 2, right 1. Draw a line. And it looks like they intersect here at the point 1, 2. We need to check just to be sure in case our graph got sloppy. Let's check this. Negative 1 plus 2 times 2. Negative 1 plus 2 times 2. Negative 1 plus 4. Yeah, that's 3. That's good. Let's see. 2 times 1 plus 2. So 2 plus 2. Yeah, that's 4. This is a solution to both things. So, good. Okay. Our last equation. The last one kind of is can get confusing, if only because there's some there's a easy place to make a negative sign problem here. Let's see, x minus y equals 5. So I'm going to try to get y by itself. So if I subtract x, I get minus y equals minus x plus 5. Subtracting x from both sides. However, I don't want minus y. I want y equals mx plus b. So in order to change this to a positive y, the mathematical thing we'll do is we can divide everything by negative 1. Negative y divided by negative 1 is now positive y. Negative x by negative 1 is positive x. And positive 5 divided by negative 1 is now negative 5. We basically just switched every single minus sign, is what divided by negative 1 is. Okay. So our one equation is y equals x minus 5. Or we have minus 5 is the y-intercept, 1, 2, 3, 4, 5. The slope is 1, so up 1 over 1, up 1 over 1, up 1 over 1. Up 1 over 1. The second equation, let's get y by itself, so subtract 3x, and you get y equals minus 3x plus 3. Y-intercept of 3, I go up 3. Slope is negative 3 over 1, down 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And we end up getting here. With our point of intersection here that looks like 1, 2, down 3. Or to the right 2, down 3. 2, negative. can check this. 2 minus negative 3. What's 2 minus negative 3? Minus negative. What is minus negative? How do you do minus negative? What's 2 minus negative 3? Oh yeah, plus positive. So 2 plus 3. 2 plus 3 is 5. 3 times 2 is 6. 6 plus negative 3. 6 plus negative 3 is exactly 3. Yes, this is a solution.